So today's lesson, we're going to be looking at something called completing the square. You can kind of see in this picture on the side, those are algebra tiles. So the big blue square, that would be considered an x squared. And the three green on each side and below, those are x's. So you notice we have the exact same size on both sides of that x squared. And the goal would then be to figure out, well, how many ones, how many of those yellows are going to be needed to create this to be an actual square. Okay, and what you'll find out is that as you drag the yellow ones down, there's only 5. You would end up needing more. You would need 9 total because you would need 3 across and 3 rows down in each of these cases. Okay, so we're going to be taking a look at how to complete the square and how to utilize that with quadratics and solving them and graphing them. So first off, completing the square, as I said, is creating that perfect square trinomial. Okay, we're going to use it mostly to be able to rewrite quadratics into vertex form. It's also going to be able to then solve quadratics easily using the square root method, especially if it's a non-factorable function. So if I have something written in standard form and either I'm not quite sure how to factor it or it cannot be factored, I can create it. I can force it to have a perfect square trinomial so I can get it into this vertex form, which is then leading me into the square root method. It's also going to help us to be able to identify the vertex and graph the quadratic if need be. So we're going to start by looking at what are these perfect square trinomials. So perfect square trinomials are basically quadratics that have the first and the last term that are perfect squares. The middle term is the product of the two roots multiplied, right? So if I look at the example, because I know the function up top there might be scary to some of you. 16x squared, I know is a perfect square. It's made up of 4x and a 4x. 9 on the back end is made up of a 3 and a 3. So as you can see, I put those in as my factored form, 4x plus 3, and it's squared. That is how we would factor perfect square trinomials. I knew the first was a perfect square. I knew the last term was a perfect square. And if I take those roots, that 4x and the 3, and I multiply them together, I get 12x. And if I double it, there's that 24x. So I get that middle term. So you need to check to make sure that the product of your roots does in fact equal double to get the middle term. Okay. And we have a couple more examples going down there that we'll go through together. Also, the sign that goes in between your two roots is the sign of the middle term. So it was a positive 24x. I have a positive sign in the middle. If it's a minus, like you see in the one underneath it, I'm going to have a minus sign in the middle. Okay, so it's really important that we know this trick, the shortcut of perfect square trinomials, because it brings us into completing the square. And this looks a lot more intimidating than it actually is. So on the side in red, first thing, you need to get your variables together on one side and all your constants on the other side. You must have the x's together and the constants together, okay, before you can start anything. Also, your leading coefficient has to be 1. If it is not 1, you are going to divide every single term by the leading coefficient to get it to be 1. Okay, and now here's our process. So up top, this is the given equation. X squared plus 8x minus 10 equals 0. I move that 10 over by adding it to get the x's and the x squareds alone and the constant alone. Now, this middle thing, this middle block, or the second block, I should say, is the forcing of your completing the square. You take your middle term, which is 8 in this part, you divide it by 2, you half it, so half of 8 is 4, and then you square it. I get 16. So 16 is what's going to complete my square. I'm forcing this square into the problem by adding it on both sides. So you notice I took what I had, x squared plus 8x equals 10, And I forced the 16 in by adding it on both sides. By doing it on both sides, I didn't really change the problem any because I balanced it. When I then factor the one side, x squared plus 8x plus 16, that is a perfect square, trinomial. So some people need to write out the whole factor. You get x plus 4, but that is x plus 4 squared. They're identical, right? Factors of 16 that add to 8, 4 and 4, or know your shortcut now that the perfect square is x plus or minus that b over 2, this half of 8 that we took here, there's the 4, squared, and that's going to equal the constant that you started with, 10, plus the perfect square that you shoved in there, that you forced in, 16 is where we got the 26 from. Now we really want it, to be this x plus 4 squared equals 26, because now that is my square root method. I can solve this by square roots. I cannot solve this by factoring because it did not equal 0. Really important there. It did not equal 0, so I cannot solve by factoring. I have to use the perfect square, or the square root method. Square root both sides. Square root of 26 is just the square root of 26. You put that plus or minus in there, and then you bring the x over. So this is how we're going to be solving by completing the square. We're going to force a perfect square inside by adding it to both sides, and then we're going to continue solving it by our square root method. Okay, so we're going to go through a couple of examples together in class. They're here if you want to start them and try them. And again, make sure the leading coefficient is 1 and all your constants are on the other side before you can begin anything. Real quick, number 8 and 9, if you take notice, they have to be distributed first. They're not in standard form. So you have to make sure it's in standard form before you begin anything. Okay, now, the biggest reason we want to know how to complete the square is so we can rewrite quadratics in vertex form. That's our main reason. So rewriting a quadratic into vertex form is very similar to what we just did. We just have 2 extra steps. First step, move the constant to the side with the y or your function notation. So that y equals or f of x equals is just going to stay there. You just bring the constant over. You go through the same process as we did before. When you're done now, because we're not solving anything, we want it as a function, we're going to bring that constant back over away from the function notation to the other side. So it's behind the square. And then if needed, you remove any coefficients that might have gotten attached to the function notation during the process. And I'm going to show you one of those as well. So real quick, here is one basic one. Y equals x squared minus 12x plus 18. We want to get in vertex form and identify it. So just like before, bring the constant away. Get the x's together on one side. Everything else has to go to the other. Then I force my perfect square in here. I half my middle term. I half the b. So 12 divided by 2 is 6. 6 squared is 36. So that's the perfect square I'm forcing inside. I add it to both sides. Negative 18 plus 36 is a positive 18. And then I just factored this side right away. I already knew it was a perfect square. I know the b term is going to half and get me 6. Or you can think of it, factors of 36 that are going to add to 12 are a 6. And sign in the middle is a negative 6. So once I'm here, I got to get the y by itself. I need to make it a function. Bring that 18 over by subtracting it. And now it is in my vertex form. Nice and pretty right there for me to be able to pull out the vertex, which again, remember your vertex is the value inside it with your x, opposite of it. So that x minus 6 becomes a positive 6. And the sign or the value at the end is my negative 18. Okay, the next problem we're going to do is going to have a leading coefficient so you can see how to deal with it. And it's going to bring back that stuff from chapter 2 where we had to identify all the parts of the quadratic, just as a refresher. Again, there's a lot happening here. So we have our function. We want to graph it, identify the vertex, max min value, all that fun stuff. Okay. First things first, get rid of your coefficient. I have a -2 here. Everything gets divided by that -2. Everything. You will just leave the function notation or the y value over your fraction or in the fraction form, whatever it is. Then same process. Get your x's alone. So I add the 1 to the other side. I half my middle term. So 2/2 is 1. 1 squared is 1. I add them to both sides. I factor it. And then I move things back. So I subtracted the 2 first. And then this last step, I have to get the f of x to be by itself. So in order to get that, if I started by dividing in the very top, I'm going to multiply by a -2 to get the f of x alone. You have to multiply everything by the -2. So unfortunately, it's a little blocked down here, but it comes out to f of x equals -2 is in front of my grouping, x plus 1 squared. Not doing anything inside that. I'm just sticking the -2 in front. And then -2 times -2, that should be a +4. I messed up there. Let's fix that real quick. There we go. So it's a +4. Then from there, I can get my vertex, which is a -1, +4. Axis of symmetry is your x value of your vertex, so that's a -1. It's a max because it was a negative function. So your max value is y equals 4. Domain is always all real numbers. The range is y is less than or equal to -4 because everything is below it. It's increasing on the left-hand side. It's going up first. Then it decreases. It goes down. So it's increasing from -infinity to -1. Remember, you go by your axis of symmetry. And then it decreases on the other side. So it decreases from -1 to +infinity. You can also see it as x is less than -1 for increasing and x is greater than -1 for decreasing. Okay, so you might see that every now and then. So I just want to show it to you just in case. So this is really why we would want to use our completing the square. With solving quadratics, we have all those other options. We have a quadratic formula. We have factoring. We have the square root method. This can help bring it to that point. But the main reason is for this, to be able to create it in vertex form and then analyze the graph or the function from there. Okay. And again, there's going to be more practice problems, which we will go through and practice together in class.